very appreciate the committee for accommodating my remote presentation. And my presentation is an opinionated-default approach to enhance Spack developer experience. I'll borrow some innovations from web and app because basically before I get a job in HKUST for HPC, I worked for web development for 2 years, but why I get this job is because I got a PhD before I get a startup in like doing my own startup for web and app. Yeah. So when I do my startup, I find one talk particularly inspiring. Is that the one from Dan Abramov? Is from React Europe 2016, and I highly recommend you may also check out this video. I will highlight one sentence from his talk. The visible side of the library are the features and API, but there's also invisible sides, which are the constraints and contracts. So my talk will be focused on what constraint and contract Spack is able to give. And I want to make an important point that imposing constraint will enable a cleaner workflow. This is almost true in the web and app, almost always true in web and app field. And I in this project, I want to try to see how this may work for Spack. So actually, my topic would just look like enhancing Spack developer experience or user experience by imposing constraints. So let me explain what is DX or UX. So it's more web and app term. So for developer, they want tools that they consider mentally coherent and have confidence and convenience in it. So for user, especially for Spack developers, users are developers anyway, but they are kind of more on amateur level, less patient because their main job is to get their scientific work done, right? And they depends on our size upstream and are less controllable. We can't control how they use Spack on their end. So we start with one version of Spack, like 0.23, and our journey looks like this. We start Spack install. Something looks good, of course. Spack install. Spack install along the way for a lot, and then suddenly we meet something like this. It's called unsupported instruction. This is AVX VNNI. What is this bug and why it's important is because it's highlight a lot of characteristic for this type of bug is that first is specific to certain kind of node. That's a certain kind of computing node, maybe specific to the CPU architecture. It's also package specific. Not every package can use this instruction, right? And then sometimes it lacks OS support. And what we find funny is even the official solution has a bug in it. So in general, I think the takeaway is don't expect bug count from external to decrease because the feature count always increase. So we have our bootstrap DX/UX workflow. It's a meta workflow that we start again and try to improve the DX/UX. So we start with using Spack environment because we have to do it many times. We end up some reproducible state, development some new package feature port to new system. So we got a set of new package, new system until we find some new problem. Yeah, there will be some compiler problems, whatever problems that we find. Maybe there are two copies of MPI that is not compatible. We will try to analyze and fix the root cause. And then, of course, the reproducibility and UX/DX will increase. And then let's test it again, break the whole thing down, build it again. And the three main goal for our center, we are a service center. So our three main goal is to get better for performance, of course. We have some pretty diverse and new platforms. We want to support all of these using a single code base. And also, of course, less frustration and complication for us and also for end user. And of course, package builds should work. Of course, it's not an easy thing for package build to always work, but we'll see later. So we basically borrow from web and app a workflow that start from upstream, which is likely a develop weekly, and then go into development, edge, alpha, stable, and production. So in between, we'll collect user feedback for evaluation of the version of those scientific apps or library if they find any bugs or so. The problem we feel in Spack for DX or UX is that bugs often depends on an enormous unknown state, including the specific set of hardware, external package from OS, and then also the exact order of installation. So it's very hard to isolate faults. For example, you have some fault here. If I create another environment of Spack and try to reproduce this, couple of times we can't because the concretizer somewhat depends on the order of the installation. And I want to highlight that if at some point that we struggled, we put most of our effort in supporting user, then if I were a user, then I should have given up because as a user, my main job is to do scientific investigation and not to compile a package. So they seek our help, we dedicate to help. So we try to struggle with that. Yeah. So if our given upstream is tricky, and the UX must be worse because you build on a shaky upstream. So this overall can contribute to some high churn rate and steep learning curve. So we look at some solution. One is whatever as code and declarative paradigm is that we expect whatever we want to build as code. Specifically, we can do, for example, YAML, which is declarative. And then what we get from the constraint is these becomes composable, debuggable, and stateless as much as possible. So we look at Spack and see what do we have now. We have Spack config, Spack environment, which are both written in YAML. They are declarative, can be version controlled if you just isolate them in a repository. But do we get the contract back for being composable, debuggable, and stateless? Somewhat not, because as I mentioned, concretizer depends on the existing package, the global package you own. And it also depends on the order of installation and their external system state. So how do we recover this? We also borrow some idea is we try to mimic the XS code paradigm. So we take the configuration and take the Spack environment. We only install the environment with -u -f and then install only concrete. So it becomes a two-step process, fresh concretization and then install. And we always disable reuse and unify. Up to this point, it's not yet composable. We have to write package modifiers into package prefer require conflict. I'll give you one example here. For example, if one environment requests OpenMPI plus legacy launcher, another didn't specify, then using this method, you will get 2 pieces of MPI. Maybe you have done testing on this piece of environment A MPI, but not the second. The second may not work. So what we do is we write in the config file requires plus legacy launcher. Then we have 2 pieces of MPI concretized to the same hash. So this same hash is the key to reuse. We are able to recover 2 of them here. And then another experience I want to highlight is we try to think back what the web is at year 2000. We have IE6, Opera, Firefox, Navigator, all with different default style. And then we play something called cascading style sheet, which means you inherit all these different styles and then try to build your own on top. So with this JavaScript incompatibility, you likely get some mystery box of your web display. So the solution they get in the web community is to reset all the CSS, try to minimize the cross-browser difference. And if it's not possible to minimize the difference, try to fall back to detect the missing feature. For example, no camera, no media stream. So for Spack, I think it means something. For example, hardware, OS kernel, compiler, etc. So what is our attempt is we try to bootstrap a known good GCC before doing anything, and always prefer Spack build package when possible. So the minimal reset baseline is pretty simple. 33 line. You can find it on the Git repository for this environment. So it also concretized with 33 package. I just recently tried that on Fedora 42 and find that, oh, it needs a new flag. The main point is if this environment build fails on an OS, then address the OS compiler issue. It's never ending to add external. Yeah, I have learned the hard truth that I have after install 10 package and find that only this thing work. But also think that this is a compiler sanity check too. So at this point, we almost align Spack with other Python conda mantra. So the mental model are almost similar, except one thing is called environment location. So what it is actually we find that pairing all environments and the user scope package config becomes one environment. So it's a big environment that can be broken down into pieces of smaller environments that you can progressively install one by one or with a dependency train that result in your very complicated environment, and you can test them one by one. The final thing I would like to highlight is because Spack is source build, more than 50% of build failure is from compiler or common prerequisites missing or compiler bugs. So I would suggest that for the tutorial, we should include more system prerequisites that is not buildable with Spack. For example, kernel header, KMOS that needs to be installed on kernel. Some library, I'm not sure if is a bug or not. As some of you might previously mention that the CMake would find the system package. I think this is related. And one thing I find very helpful is to always have compiler smoke tests. So basically, you can look at this environment. The Spack is just a matrix of all the targets, all this one API compilers in different versions. We test the auto tools, test the CMake, test the makefile, test something that has ASM in it. So we quickly discover that how we think compiler work is not how it really work. Because for a lot of compiler, they do not support some microarchitecture. The tool chain might be broken at some place. There are also some compiler bugs and I would call it features. I don't know. These don't have quick fix because it's other issues, not a Spack issue. But as long as we know that there is an issue, for example, one API 2021 can't deal with SAM4, so we just don't use it. It's fine. So for example, we find these list of bugs. For example, something deal with CMake plus AS plus ran live incompatibility on Red Hat 9 and related to this one. For example, one API 2024 to 2025 plus IPO will fail. We have some PRs here too. Yeah, there's funny bugs. I don't know why, but some I don't even know why. But you can at least know that it doesn't work. So for project status, we are serving a lot of our user with Spack. It's our main package manager, and also offer LMOD from it. And we install GUI to performance demanding library and use it to help a lot of combinatorics testing and easy to switch to new config. And I just recently do this and is try Fedora 42 with kernel 6, and at least I can get Intel compiler working very quickly on a SAM5 computer. So here are tools repository that you can refer to for any environments or config. Yeah, thank you for listening to this talk, and I'm very thankful for the Spack community. Particularly, I think T Gambling and MP. I don't know them in person, but I know that their name in the Spack group. Yeah. Thank
you so much. Don't really have time for questions, but maybe as our next speaker gets up, we could get one. Oh, go for it. Todd.
Do you find that this is Todd, so I'm T Gamblin on Slack. Do you find that you get a lot of duplication when you use unify false? I mean, I get that it makes your environments composable and not sensitive to each other's state, but unify true is there because a lot of people wanted less duplication.
We actually find unify false if you write all composable defaults into side package config, then you actually have less duplication. For example, for our default environment, we only have one MPI for each of the MPI version. So, in that sense, we have, for example, I can show you that it's like we have one environment that is responsible for installing MPI on GCC, another environment for installing MPI on maybe Intel one API, and then we take those MPIs and then have another environment that install maybe HDF, NetCDF, those kind of things, and they concretize to accept the same MPI version. So it actually, if you do it write all the prefers required into the config, actually it results in less duplication than using the auto duplication. The one thing I don't like about the auto duplication is sometimes I really need a duplicate and it's snapped to some often snapped to something that isn't the way it should work.